Hello. So today I'm going to kind of give you a brief overview of the periodic table of elements and the expectations I'm going to have for my chemistry classes. The next unit we're going to be diving into is atomic structure and more of a in-depth look of what the periodic table is all about. But for this first unit, I want to kind of give you an overview of what it is, what I expect in this class, and some tips to help you study for the expectations I want to give you. So first off, just a little bit of background. The first periodic table was developed by Dmitry Mendeleev. He was born in 1834 and he died in 1907. The reason why I put these dates up is that I want you to know that the periodic table has actually not been formed for very long. The first periodic table only appeared over 100 years ago. So it hasn't been that long in retrospect of actually having a tabular form of all the elements. And also it demonstrates here in a little bit how many elements we've discovered in 100 years is actually quite phenomenal based off what Dmitry actually only knew at the time. He only knew about, I think it was like 20 or 30 elements, and now we have over almost 120 elements on the periodic table. So it's pretty fascinating on how quickly we've actually discovered a lot of new elements based off what he started way back then. How he kind of developed it is that he noticed that the atomic weights of elements would develop patterns. And how he based this off is that the patterns corresponded to physical and chemical properties of each element. He noticed that as the atomic weights went up, that patterns would start to evolve based off their particular weights. So in correlation, if you started at one element and went up a weight of a certain amount, you would notice that they have the same physical and chemical properties of that. And that's how he started outlining the periodic table. But the most genius thing that he did, which really kind of is really baffling and very stroke of genius for his time especially, is that based off these patterns, he left gaps in the original periodic table because he believed that there were still elements in the world that had not been discovered yet. He knew based off the pattern that there should be elements in between other ones that we already knew about based off the patterns that he was developing. And so this helped set it up after he passed away. When we started getting more advanced technology and everything, this set scientists up to say, okay, let's see if he was right. And they started evaluating it, and they found that he was right, that there was elements in between the elements they had known at the time. So it helps set up a lot of great research for a century to come. And honestly, I think he's one of the greatest forefathers of science just based off of this. So I really, as a scientist, I really like that idea, and it's something that even some of the simplest ideas can be the biggest stroke of genius in the scientific community. Again, the first periodic table was published in 1871. So he was, 37? So, I mean, in retrospect, he wasn't that old, okay? Even back then. So, I mean, youngsters can make differences too. Mark Zuckerberg, maybe not Mark Zuckerberg, but you get what I mean. If you can read the periodic table correctly, you can conquer chemistry. Seriously. The periodic table holds all the secrets pretty much to chemistry. And if you can accurately read that, as you go on in your scientific journey, not just in my class, but into higher levels of science, you'll start adding more and more and more to how to read the periodic table to a point where you can start pointing at a particular element like it'll do this to that and blah, 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 blah. And this ability to predict allows scientists to set themselves up for the best type of research, in my opinion, that can help progress the world in a more advanced way. So I believe it as a chemist and as a teacher. If you can read the periodic table correctly, you can conquer this class. You can conquer chemistry and the scientific world in general. Over the years, there have been many versions of the periodic table. The newest version was just created a couple years ago in November of 2016 with 118 elements. They just recently developed or synthesized, I think, 4 or 5 new elements, and they just gave them names to it. And so it's really cool because this is the actual current periodic table as of right now. The periodic table 20 years ago was only up to about this point. Around about 110. So within the last 15, 20 years, we've discovered this. And what's really cool is, and I know you probably don't get this, I really find it fascinating, is that when you start getting to these elements on this row, they start becoming really unstable, which is the reason why we have to synthesize these elements. because they only appear for a few seconds at a time, a few nanoseconds at a time. But they're still there. They can still be developed. That's the reason why we can put it on the periodic table. We can actually prove that we can make these elements. But the cool thing is in theoretical chemistry is that when we get to this 7th row, there's a theory that elements will start to become more stable, which means the hope is in the next maybe 10 or 15 years they can start developing new elements that show up on the left side of the periodic table to where we can actually physically hold them in our hands for longer periods of time, which hopefully will lead to new technologies and so on and so forth. So yeah, this is currently the periodic table as of right now. So a couple of periodic table basics. Element. We've already kind of talked about this a little bit. It's a pure substance that cannot be broken down or separated into simpler substances. Hydrogen is hydrogen. Can't break it apart. Now, I know some of you guys are saying, what about Higgs boson and stuff like that? Okay, it's the simplest form of something that can be on the periodic table. Okay, an element is made up of protons, neutrons, electrons, so on and so forth. But an element itself is a cohesion of all those subatomic, which is the reason why they're called subatomic particles, to form that element. Okay, that element acts as a single unit. It's the simplest form that can be described on the periodic table. Chemical symbol. It's an abbreviation use to indicate an element, which is highly, highly important. This is the whole point of reading. Like symbols are the words of chemistry. If you don't know what a symbol means, then you're going to have a really hard time doing any chemistry at all, which we'll definitely dive further into, and you'll have plenty of practice doing that. An important note, though, some chemical symbols contain at least one capital letter, and either does or doesn't contain a lowercase letter. The reason why is just depends on when those elements were discovered. When scientists discovered elements, they decided to assign either one symbol, one capital letter, like hydrogen, and then when helium was discovered, people were like, well, I want to call it helium, but we can't just call it both of them H. So they said, oh, we'll put HE, and so on and so forth. So chemical symbol rules, excuse me. The first letter of the chemical symbol is always capitalized, always. The reason being is that if you don't capitalize the symbol, it can, in mathematics, kind of mess up some math that you're doing in regards to notation and everything like that. So it's very important to always capitalize the first letter of the chemical symbol. The second letter, if it is present, is always lowercase. You never have two uppercases because two uppercases will indicate two different types of elements. If you have an uppercase and lowercase, it determines that that set of two letters is one particular element. So a couple examples, hydrogen is just H. Helium is HE. Okay, so if I saw HE, it would be helium. But if I put HW, okay, that would be hydrogen and tungsten together. If I had HE, then that would be H and Einsteinium or something like that. So it's very important to know how to notate these things, how to write them, and so on and so forth. So here are the expectations for my class. Now, a lot of y'all are going to think this is completely out of proportion, like just out of this world. It's not. Trust me, it's not. The more you see these, the better it'll be. Plus, this is just based off how I've seen other classes do it, how I learned it when I was in high school, and so on and so forth. So I've been through this. It's not that bad. Don't worry about it. I'm going to give you a couple of tips on how to help you with this. But in my class, you will be responsible for learning and memorizing a total of 70 elements. Okay? You'll need to know both their chemical symbol and the correct spelling for each element. Okay? So you need to practice this. So just kind of break it down. When you look at an element block on the periodic table, the chemical symbol is the big, huge letters there. So the capital T, little I means titanium. And then the chemical, that element name is the right there. And that's how you should be able to spell it. Now, and we'll talk about this a little bit more in class, there are some elements that have different types of spellings. And there'll be some exceptions to that because of how those spellings have changed over time. There's only like 3 or 4. So we'll talk more about those later on in class. Don't worry about it. So the way I'm going to evaluate you in my class is it's going to be broken down into 5 rounds of quizzes. Okay, and I'll tell you when these quizzes are going to occur. But the first round is that you'll be responsible for knowing the first 18 elements, 1 through 18, hydrogen to argon. You should be able to write the correct chemical symbol and write the correct element name for each one. Okay. Round 2 will be the second row, which is 19 through 36, so that's potassium through krypton. Round 3 will be rubidium through xenon. Round 4 will be a select couple. So after we get to the fourth row, we start getting into transition metals and a lot of other stuff going on with the periodic table, which we'll talk about further on. Based off the context of the problems I'm going to be giving you in this class, there's only so many elements after that that you really need to know about, both in regards to practicality of what you may see in real life a lot, and two, just based on how they really work chemically at a very, very novice sense, something that's really easy. So round 4 is consisted of all of these elements. So that's something you're going to need to write out and write down. That way you're not memorizing elements that you don't need to. Okay, if you want to memorize more elements, go for it. But I'm not going to quiz you on any of those other elements besides this, nor should any of the problems that I use any different elements besides this, because that will throw you off. Okay, if I do, call me out on it, because I'll change it. And lastly, round 5 is going to be a mixture of all 4 rounds. Depending on the class, I may make this a quiz grade or a test grade. I don't know yet. But I will announce that in class. But round 5 will be a mixture of all 4 rounds. It'll be fair game to pull from anywhere out of those 70 elements to assess you on. So be aware of that. But tips for learning the elements. Okay, big thing. Okay, I hate tests. Okay, I'm not very good at tests. I have developed a lot of good study habits in my years on this earth, and I'm still kind of not good at it, but that's okay. That's fine. I know everybody takes assessments differently, and so what I want to do is I want to give you a couple of tips that may help you based off what I've seen in other classes and what I've been exposed to throughout my academic career. The most easiest thing is making flashcards. So what you can do is have one side of the card be the correct spelling of the element and the other side be the correct chemical symbol. What you can do is you can put it on like a key ring, and then you can flip through it, and like you can just practice. Oh, H is hydrogen. H-Y-D-R-O-G-E-N. Okay, hydrogen. Okay, and you can flip and double check your answer, and then you can do it vice versa. Hydrogen. What's the chemical symbol for that? Oh, H. And then flip it and check your answer. What I highly recommend is studying these individually a few minutes at a time. It's scientifically proven that if you chunk it up, you will remember it better. Do not cram for this in one night. You will fail. Okay, I don't want you to fail, but you will fail if you do that. So what I highly recommend, keep it in your backpack. If you're on your way to a soccer game, or you're on your way to the movie or a restaurant and you're at a red light, just whip it out, do as many as you can in a couple of minutes. Do it a couple of times before you go to bed each night. So on and so forth. So that's what I highly recommend. You will study better that way if you do it in flashcard form. I would also study with your friends in smaller groups. Quiz each other. That's always fun, I think. And that way, your friends can kind of keep you on your toes. When you're at lunchtime and you have nothing to talk about, which I'm sure you have plenty of stuff to talk about. Quiz each other. So I highly recommend doing that. Quizlet is an app that you can actually have on your phone. I actually have it on my phone. I have it on my phone right now. And it's a electronic form of flashcards, but it also has games and stuff that you can do with it too, like to type it out and stuff like that. So it's in different formats on how you can memorize things. If you go to Quizlet.com, or if you download the app and you look up Harville Chemistry, you will look up and find a set of notes or flashcards that I've developed called Round 1 Elements, Round 2 Elements, so on and so forth. And you can do it in different formats in which you can learn. It can just be simple flashcard form, or you can put it in like a typing game or something like that you want to too. So if you want to explore that, feel free to do that. Again, you can download it on your phone and have flashcards on the go. Play other types of games and so on and so forth. So that's it for this video. If you have any other questions, expectation-wise, or other ideas to maybe study for this, please come talk to me. Email me, whatever you need to do. But I'm going to be giving you a lot of time to look into this stuff. Again, we'll start diving a little bit deeper into the periodic table next unit. But I kind of want to just give you an idea of what to expect in my class, what I expect of you, what I expect of myself as a teacher, how to evaluate you and stuff like that. So if you have any questions, please come talk to me. Otherwise, thanks for watching this video, and hope to see you in the next one, and I hope to see you in your class. Bye.